Hello, Algebra 1. It's been a while since we've met this way, but coming to you is a sweet YouTube review of how to write equations of lines. So you should be following along with me. I've printed a note guide for you to complete notes with me, and you will have an assignment after. But like I said, this is review. It's review from first semester though, so that was a long time ago. And or some people might not have been with us first semester. So it's a review of first semester that we will be using next week. So I thought it was a nice kind of easy thing to freshen up on today while I'm out. So the objective today is to be able to write an equation of a line. So again, this should feel familiar, but it's familiar from, back in probably October. All right, here's where you begin notes with me. So there's really three ways that we're going to end up writing equations of lines today. The first is from a graph. So if you're given a graph of a line, then we know that our ultimate goal is to write that equation in slope-intercept form, which is y equals mx plus b. Why is it called slope-intercept form? Well, because m just stands for slope. Excuse my handwriting with a stylus. And b stands for the y-intercept. Now, if we have a graph, then we can just look for the y-intercept. So I'm going to look for that point first. It's where it crosses the y-axis, which is this vertical axis. You can just look for that point where your line crosses. Once you find that point, wherever it is, that's your b. The slope, remember, is a measurement. We use m, but it's a measurement of rise to run. So once you have one of the points on your y-axis, you'll then count rise over run to the next point to find the slope. And that can be a fraction or it may simplify to an integer. Let's see an example. So here are two lines graphed for you. We should be able to write the equation. Well, in order to do that, we need to know m and b. Again, b is the y-intercept, so I'm just going to look and see that this first line crosses the y-axis at -2. Now, this one has been so nice as to draw other points for us. So from my beginning point, I'm just going to count from there to this next point here. So what is the rise and the run between those 2 points? Well, I would count up 1, 2. So up 2, and then over 1, 2, 3. So 2 up 2 over 3 makes my slope a positive 2/3. So I can now write the equation of this line. In slope-intercept form, it would be y equals m, which is 2/3, x plus b, but in this case b was negative, so I'm just going to put a -2. So let's look at the second one. I would start it by doing the same thing. I'm going to find m and b. I'm actually going to I always thought of b as begin, so I will begin on the y-axis at +2. Now this time they didn't give you a clear point on the graph, so you're going to have to find that point yourself. So here's another point where my line intersects the graph nicely. So I'm going to count from my beginning. I would go up 2, but then notice I went backwards. So that makes my slope -1. So if I divide 2 divided by -1, I would get a slope of -2. Now hopefully it's obvious that this is a negative slope because we can see the line is slanted down. So when I throw those into the slope-intercept form, y equals -2x plus 2 is the equation. All right, I'll give you a second to try these two. For example 3, hopefully you began at 3 for your y-intercept. Here would have been the next nice point. So I could count the rise as 2 and the run is 1. So up 2 over 1 just gave me a slope of 2. When I put that into y equals mx plus b form, then I get this linear equation. And for example 4, it started at +1, and the next point you could have used this point, or you could use this point, right? Either way, when you count, you would go up 1, and in this case, backwards 2. Or you could have gone down, which is negative, and then right. But either way, you get a negative slope because, again, this line is slanted down. So the equation of this line is y equals negative 1/2 x plus 1. All right, so that's writing the equation of a line from a graph. Now, remember, we also wrote equations of lines if we were just given information about that line. So in this case, I'm given information about a point that's on the line and the slope of the line. So remember, slope is m. So in this case, I'm given m equals -2. And a point is always an ordered pair, x comma y. Now remember, that's when we put the little subscripts x1 and y1. So we were given one of the points on the line. And here's a familiar formula that's probably long been erased from my board, but this was called the point slope formula. So with everything labeled, we can just plug into our point slope formula. So y minus y1, which is 5, equals m, the slope, which was -2, and then x minus x1, which was 3. So I'm just plugging each of those values into this point slope formula, and then I'm trying to still get my y equals equation. So I need to distribute the -2, so that becomes -2x plus 6, because I took a negative times a negative. And then I want to get y equals. So instead of the -5, I'm going to plus 5 to move it to the other side. So now I have y equals mx plus b, which is -2x plus 11 for this example. So that's how we wrote the equation of a line if we had a point and a slope. Remember this important formula, write that down somewhere safe. I have a feeling you'll use it a lot today. Last but not least, we could write the equation of a line if we just have 2 points. So remember, if I have a point and another point, there is a line that goes through those 2 points. We should be able to come up with the equation of that line. So this time I have 2 points. So an x1 and a y1, and then another x and another y. So we give those subscripts of x2 and y2. So this one is one extra formula we have to remember. If I have 2 points, well, first I need to find the slope between those 2 points. So here was the slope formula. If I don't have a picture and I can't just simply count rise over run, then I have to think rise, well, that's the change in the y values, over run, that's the change or the difference of the x values. So labeling things will be very important because now I just plug them in. So y2 was -1 minus y1 was 5. x2 was 1 minus x1 was 3. Now, we could grab a calculator or just be a little careful here with your integers. -1 minus 5 would give us -6. 1 minus 3 gives me -2, and I know a negative divided by a negative is a positive. So my slope, m, equals 3. So I'm going to use that information along with the x1, y1 information, and now I'm going to go back to that second formula, that we just wrote down, and I said, hey, remember this, we'll use it a lot, right? So maybe this is bringing back memories of that test we took and just how often we use this point slope formula. Well, now I found the slope right here, and I was given an x1, y1 point from the beginning, so I can plug those in. So y minus 5, the slope we found was 3, and then x minus 3. So it's just plugging into this point slope formula and then distributing. So 3 times x minus 3 times 3, and solving for y. So instead of a -5, I can plus 5 to my like terms. So I'll get y equals 3x. Of course, the slope was 3. We knew that. But then -9 plus 5 is -4 for our y-intercept on the end. All right, so this will be our last one. See if you can pause the video and at least try starting it without me. All right, the first thing I did was label my points, and now I need to find the slope between those 2 points. So using the slope formula, the difference of y's, so the y values 1 minus 5, and the difference in x's, and I have to go in that same order. So I'm going to do -4 minus -2. Now again, this is just make sure you grab a calculator or be careful with integers. 1 minus 5 is going to be -4. And then here, remember, minus a negative, we actually like that because a keep change opposite, that just becomes plus plus. So -4 plus 2 is -2. And just like in the previous example, a negative divided by a negative is a positive. So my slope came out as a nice positive integer again. Now that doesn't always have to happen. Remember, you can get fractions for slope. That's okay too. But I got a nice whole number here for slope, or for my m. And then I'm going to use my x1, y1 to again plug into this all so familiar formula. We had it memorized perhaps once upon a time, and maybe we remember it already. So this becomes y minus 5 equals 2x minus -2. I need to distribute. Again, I see that minus a negative, so I'm just going to think of that as plus. So that really becomes 2x plus 2 times 2 is 4. And then I need to get y by itself. So I'm going to add the 5 to the other side and combine my like terms to get y equals 2x. Again, we knew the slope was 2. And then 4 plus 5 gives us a plus 9 as our y-intercept on the end. So that's a recap of how to write equations of lines. Notice our final answer is always in slope-intercept form, y equals mx plus b. In this equation, or in this example, I had to use 2 formulas to get to my final answer. If you have a graph, I would argue those are the easiest because you can just look at the graph and find m and find b. So no formulas really necessary there. So make sure you've written down these formulas. You can always go back and watch this video on Google Classroom if it went too fast and you need something else explained. But if you remember these examples, then you now have an assignment. You've completed your notes, so you have an assignment waiting for you on Delta Math over all 3 of these different ways to write equations of lines. You have an excellent sub who is also very good at math, so feel free to ask him for help. He's more than willing to help, and hopefully you can get this done in class today. What's not done becomes homework, so this will be due on Monday, so please use your time wisely.